So this question is a diagram question. Any question that provides some visual input, I'm going to call a diagram question. Looking at this diagram, looks like we have some values provided in our first column, and then we have a frequency of those values that constitute data set A, and a frequency of those values that constitute data set B. The question goes on to say data set A and data set B each consists of 27 values. All right, so let me just make sure I understand that. So data set A, so that means there's 2 30s, there's 4 34s, there's 5 38s, there's 7 42s, and there's 9 46s. And altogether, that should add up to 27 total values. The same for data set B, there's 9 30s, 7 34s, 5 38s, 4 42s, and 2 46s that make up that data set, which should also consist of 27 total values. So the table shows the frequencies of the values of each data set. We see that. Which of the following statements best compares the means of the two data sets? All right, well, how do you find the mean? Well, you find the mean, first of all, knowing that the mean is the same as the average, which means you're finding the sum of values divided by the number of values. So we're gonna find the mean for each data set. We know that the number of values for both is 27, right? So we know that for data set A, we have 27 values, and for data set B, we also have 27 values. So those would be our denominators. But what is the sum of the values? So for data set A, the sum of values would be 2 times 30, right? Because there's 2 30, so that makes it 60. I'm gonna use my calculator again here. 4 times 34, right? Because there's 4 34s, which would give us 136. And there's 5 times 38, because there's 5 38s. That would give me 190. There's 7 42s, so 7 times 42. That gives me 294. And there are 9 46s, or 9 times 46, which gives me 414. All right, so the sum of all that together, I'm just going to add them all up. So I'm just go backwards, 414 plus 294 plus 190 plus 136 plus 60. I get 1,094. 1,094. Let's do the same thing for, actually, let's find the answer. 1,094 divided by 27 is equal to 40.5185. So there's our average, or our mean, for data set A. For data set B, let's do the same thing. I'll do it here, though, slightly differently. So everything I'm going to write on the screen now is what you can input directly into your calculator. So here we'd have 9 times 30 plus 7 times 34, again, because there's 7 34s and 9 30s, plus 5 times 38 plus 4 times 42 plus 2 times 46. So now I'm going to go to my calculator and just see what all that ends up giving me. Let's just start over. 9 times 30 plus 7 times 34 plus 5 times 38 plus 4 times 42 plus 2 times 46 in my calculator. And from doing that, I get 958. So that's my numerator here. So then obviously that's going to be smaller than for choice A, but let's just find the actual number. 958 divided by 27 is equal to 35 5.481, let's call it 5. Okay, so the mean of data set A, I'm looking at the answer choices now. The mean of data set A is greater than the mean of data set B. Absolutely, right? 40.5185 is greater than 35.4815. So I like that answer. Choice B, the mean of data set A is less. Absolutely not. Choice C, the mean of data set A is equal. Absolutely not. Choice D, that there is not enough information to compare the means of the data set. Absolutely not true, right? So choice A is the best answer to this question. And again, all we did was find the means. So the trick here is some of us are not so used to finding the mean or the range or the mode or really any of those types of values when we have data set up in a frequency table. So just keep in mind, like, this is the way to think about it, right? So this is, of course, for data set B. I could have done the exact same thing written out for data set A. But realistically, what's happening here is we have this list, right, where there's 2 30s and there's 4 34s for data set A. And there's 5 38s. And so on and so forth, right? So again, that is how we know how many values we have and the number of repeating values that we have. And then we're just finding the sum of all those values for our numerator divided by the total number of values we have for our denominator in order to find the mean.